Okay, let's look at our second example for integrating products and quotients by substitution. So in this case we've got a quotient and we have to decide what to make our substitution to be. Now it's a difficult choice for many students. Should you do u over x plus 1 root, or should you do x minus 1 over root u, or should it just be straight u? There's lots of questions. Now the thing is, any more than one substitution can work, but some substitutions won't work. So in some instances you'll make a substitution and you'll get somewhere where you realize that you can't actually do it that way. So you've just got to make a sort of an intuitive guess, but often a good strategy is dealing with the most complex part of the function. So here the most complex part is really the square root part. So the substitution that I'm choosing is to replace x plus 1 with u, and so that will just leave me with root u on the bottom. Okay, in fact I will write that over here, okay, where u equals x plus 1, therefore x equals u minus 1, and we can say that dx equals, if I differentiate that, I'll get 1, so it just equals du. So I can substitute for x, and that will give me u minus 2 on the top, and the denominator is the square root of u. And I'll just separate that because it will make it easier for me to integrate. And because dx equals du in this case, I can simply replace dx with du. Okay, so simplifying this a bit further, I can write the first term as u to the power of a half, so that's just cancelling out my powers, and the second term is negative 2 u to the negative a half, so writing it in index form. Alright, so for the first term we're adding 1 to the power, so we're going to have u to the 3 over 2, and dividing by that new power. So instead of dividing by 3 over 2, I'll just write it as the reciprocal, and then we've got the same here, negative 2, increasing the power by 1, so that's a half, and dividing by the new power, and of course dividing by a half is the same as timesing by 2. So we've got that there, plus our constant of integration. So tidying this up and bringing our substitution back in, I'm going to write it as 2 cube root of x plus 1 all squared, so that's just changing that power into third form, over 3 minus 4 x plus 1, that should just be square rooted, and then plus c, and that's my integral. Now you can write it with this part as one term, but it's not really necessary. In NCEA you're just looking for the integral, and that is your integral, so that's sufficient. Okay, so there's the work that you need to do to practice these styles of questions.